Lesson 12.2, Surface Area of Prisms and Cylinders. The surface area is the sum of the areas of each surface of the solid. Surface area is the area of the surface. Wow. In order to calculate the surface area, sometimes it is easier to draw all the surfaces. These drawings are called nets. What you do is imagine cutting the three-dimensional figure along the edges and unfolding it. Start by drawing one surface and then visualize unfolding the solid. So for this box, maybe I draw the front. And then I have the two ends, they're squares. And then, oh wait, there's the top would unfold and the bottom would unfold. And then there's the back, so maybe it would unfold there. That would be a net. So our left, right, our front, our top, our bottom, and our back. To find the surface area, then add up the area of each of the surfaces of the net. Or you might look at this and notice, oh, the middle, the top, front, bottom, back make one huge rectangle, and then we have the two squares, the two bases at the end. All right, before we do all that, we have some more vocabulary. Parts of a Wright prism. The bases are the congruent parallel sides. So that'd be, in this case, the top and the bottom. Bases doesn't mean top and bottom, though. It just means the parallel congruent sides. If this prism was sitting on a side, then the bases would be the left and the right. The lateral face are the other faces. So the faces that connect the bases together. And they will always be parallelograms in a prism. The lateral edges are the intersections of the lateral faces. They're parallel. So that's a lateral edge, and that's a lateral edge, and that's a lateral edge, and that's a lateral edge. The altitude would be a segment perpendicular to the planes containing two bases. So the altitude is perpendicular to the bases, and it's like the height. Oh, let's write that one down. It is the height of the prism. Look at that. The height is the length of the altitude. Now, if this was sitting on its side, so the base is where the left and right ends, the altitude would still go between the bases and it would be sideways. And so the height would be sideways. So remember, the base and the height are perpendicular. Base and height are perpendicular. Base and height are perpendicular. Height and base are perpendicular. A Wright prism is a prism where the lateral edges are altitudes. It's usually what you think of when you see a prism. So here's the altitude, the base, other bases down there. So our lateral edge is perpendicular to the bases. So our lateral edge is an altitude there. An oblique prism is a prism that's not a Wright prism. The altitude would go straight up and down, whereas the lateral edge is slanted there. So Wright prisms, the lateral edges are perpendicular to the bases. Oblique, they're not. The lateral area of prisms would be the area of the lateral faces. And that would be the perimeter of the base times the height. Just think about that net we drew at the beginning. Looks something like that. This is the lateral area. All right, that means this is the height of the prism. It's because this is the base, and that's a base, and that's a base. The height's perpendicular to the bases, and so that'd be the same thing there. And then this, that would bend all the way around the base. So that would be the perimeter of the base. Well, this is a rectangle. Area of a rectangle is base times height, length times width, whatever. Anyway, it'll be the perimeter times the height. The base area, the bases are congruent, so if you want the total base area, you just find the area of one base and multiply by 2. This gives us the surface area of a prism. Surface area is 2 bases plus the lateral area. So 2 bases plus lateral area, or 2b plus ph, where S is the surface area, B is the base area, P is the perimeter of the base, and H is the height of the prism. Remember, height is just the distance between the bases. Draw a net for a triangular prism. So a triangular prism is going to look something like this. So imagine taking the triangle and drawing it. So it'll be like here. And then the triangle on the other side, be there. And then we have this piece in the middle there. If I unfold, then I have the bottom, and then the slanted side that connects the slanted parts of the triangle. Just take it and unfold. Find the area and surface area of a right rectangular prism, height 7 inches, length 3 inches, and width of 4 inches. Alright, so there's a picture of it. It's a rectangular prism, which means the bottom's a rectangle. And it's 3 by 4, and the height of the prism is 7. So I made the bases, the top and bottom. The height goes up and down between them. Alright, if I'm going to find the lateral area, remember lateral area is perimeter times height. So I need to find the perimeter. Perimeter of a rectangle, which is our base here, is 2 lengths plus 2 widths. So it'll be 2 times 3 plus 2 times 4, which is 14. Our lateral area is the perimeter times the height. So it'll be 14 times 7, our height's 7, which is 98. So the lateral area of this right rectangular prism, otherwise known as a box, is 98. The surface area is 2 bases plus the lateral area. So the base area, the base of this is a rectangle, and its area is base times height, or length times width, so it's 3 times 4, or 12. So our surface area is 2 bases plus the perimeter times the height. So that would be 2 times 12 plus 14 times 7. The area of the base was 12, the perimeter was 14, the height is 7. Add those together, you get 122. Cylinders are the same as prisms, except the bases are circles. So that means our lateral area, which is perimeter times the height. Oh, wait, the perimeter of a circle is the circumference, which is 2 pi r. And the surface area will be 2 times the area of a base. But wait, the base is pi r squared. So it's 2 times the area of the base plus the perimeter times the height. So this is the same thing as the prism, only the base is a circle. The surface area of a right cylinder is 100 centimeters squared. The height is 5 centimeters. Find the radius of the base. Alright, well, let's see. It's talking about surface area. So we could use surface area is 2 pi r squared plus 2 pi r h, and fill in what we know. We know our surface area. We know our height. And we're looking for the radius. So I filled in the surface area and the height. All right, 5 times 2 is 10. Okay, this is quadratic because we have the r squared and the regular r. So I move everything over, make it equal to 0. Well, let's see. Probably can't factor that too much because we have pi's. So we'll probably have to use the quadratic formula. All right, what did I do there? I took and divided everything by 2 pi. Just make my number smaller. You didn't have to do that. And use the quadratic formula, fill in everything. Oh wait, the quadratic formula, if you don't remember, is not b. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Where this is a, so it'd be 1 for the a, b is 5, and c is negative 15.915. Put all those in, and I get negative 5 plus or minus the square root of 88.662, all divided by 2. Put that in the calculator, and I get 2 answers, 2.2 and negative 7.2. Well, the radius has to be positive, so only the 2.2 makes sense. So we're going to not count the negative 7.2. So it'll be 2.2 centimeters. Find the cylinder surface area. Surface area is 2 pi r squared plus 2 pi rh. Well, the 5 is our height, the 2 is our radius. Fill those in. Radius is 2, height's 5. All right, here we have 2 squared is 4 times 2 is 8. Over here that's 10 times 2 is 20. So we have 8 pi and 20 pi. Add those together, we have 28 pi's, which is our exact answer. If you put in your calculator, use the pi button, you get whatever 28 pi is. I'll accept either 28 pi or the decimal.